Hello everyone, my name is Yiğit. Today I'll be talking about debugging the Smarthome, giving you an introduction to Test Suite and Smarthome Analytics. These are the two debugging tools which we brought significant updates over the past year. Before I start though, this live stream is going to be recorded and continue to be available online after the event. If you get any questions on the subject, we do have a live Q&A moderated by my colleagues as we go on over the next 24 hours. So be sure to ask your questions over there. So starting with the talk. There are three fundamental questions that I want to answer for developers. How can I monitor my project reliability at scale, get more insights about my errors, and test my integration over time? To answer these questions, we are going to do a deep dive on our debugging tools. Smarthome Analytics is a set of tools available on Google Cloud Platform to monitor your project metrics and analyze your logs. And Test Suite is an online tool that creates an automated test plan and executes it against your Smarthome integration. During this talk, you'll be hearing a lot about metrics and logs. Metrics are counters that represent the user interactions with your devices and provide breakdowns on various components. And logs are JSON-like strings that contain the details, which is especially useful for things like capturing an error message. I put a high-level example for both on the slide. You see the metric contains the aggregate data, and the log provides details like device type, trait, and an error message. So essentially, metrics help you to determine where your action is having trouble, and logs are useful when making a deep dive to solve these problems. Our goal is to create a debugging loop using these tools where you start by checking the metrics, see the gap in your success rate, identify your top error, search this in your logs to see the error description, and hopefully you'll be able to utilize that info to fix the issue. There are lots of metrics we provide to your project, such as the success percentage, average latencies, daily active users, error breakdowns, and so on. So knowing these, we'll go through our debugging the Smarthome codelab. This is a codelab that builds on our previous Connect Smarthome devices to Google Assistant codelab. I'll use the same project created over there by updating the code with our new codelab. The code does contain the same virtual washer, but we have planted two errors that we'll try to solve using our debugging tools. The codelab is accessible following this link, and I took some screenshots so we can walk through together. So you'll see the first page outlines the actions you take before you begin. It lists two prerequisites. Familiarize yourself with the steps to create a Smarthome action, and complete the introductory codelab. Since this codelab builds on the previous, you must first complete the introductory codelab or have a Smarthome action that you can use as a basis for this one. And once we have the action, we'll deploy a virtual device with two defects and try to find them using our debugging tools. You'll learn how to use different features in Smarthome Analytics and Test Suite. And for the technical bits you'll need, a mobile device with Home app installed, so you can link your account and issue commands through Google Assistant, and tools like Node.js to be able to write and deploy your code. The next step is to download the source code and take a look at what's inside. Our codelabs usually come with two versions. In this instance, washer faulty is the starting version that goes with the flow of this codelab, and this is the version that we'll start with, by the way. And washer done is the finished version that you can use as a reference if you get stuck at any point. Then starting with the washer faulty, you'll see that it is a Firebase project, and a common pattern with them that they have a public directory that contains all the UI and front-end code, and a functions directory that contains the back-end implementation using Firebase Cloud Functions and a real-time databases. We'll then proceed to running our app. Through a terminal, you can change the directory to washer faulty, then do a Firebase use your project ID. This will make sure that Firebase knows to associate this directory with your project. Once you do these, navigating to functions directory and doing an npm install will get any dependencies your project will need. And once you have done all of these, you are ready to do a Firebase deploy. And Firebase will build and deploy your code to a web application. This will take a few minutes. Once the process is complete, Firebase will tell you the hosting URL that your web application is accessible. Your hosting URL will probably be in the format of your project id.firebaseapp.com. Proceeding to the URL, you are going to see a page like this showing the UI controls for a virtual washer device. If you are deploying this code on your previous project, for your new device settings to propagate to home graph, you need to issue a request sync. We have implemented this as a refresh button by the Smarthome codelab header you'll see in the UI. I've already went through all these steps before our talk, and I have my web application ready here. So as the codelab mentions, I'll just click through the refresh button here, and my smart washer should be ready to go. So getting back to the presentation, we should be ready to proceed with the next section. So the next step will be to test our action. We'll open up the home app and issue a few test phrases like, "Hey G, turn on my washer," or "Hey G, pause my washer." I do have a short recording for you in the next slide, so let's see what the results will be. Okay, I've also issued the same commands in the background. I've also recorded the conversation in writing on the right. I've issued a "turn on my washer," and the response I got was, "Got it, turning on the device." But when I issued the "pause my washer" command, the response I got ended up coming as, "Sorry, I couldn't reach," then the action name. As you see, the first request executed properly, but then there is an error with the second one. So what's going on behind the scenes? We'll start with step one, monitoring your errors through analytics dashboard. Each time when one of your users issues a voice intent, Google will send a request to your fulfillment endpoint. You take this request, execute on your devices, and give us back the result. If your result specifies an error, or if we cannot parse it, we count that as an error. For this, we'll increment the metrics and record an error log on your project. The debugging flow would include two steps: monitoring these errors, then search the error codes within your logs. Starting with step one, I do have the Google Cloud open, so our monitoring metrics will be accessible through. You go to Google Cloud Platform, you select your project. I'm selecting my test project. Then through the side menu, if you scroll all the way down to monitoring dashboards, should bring you to this page that has the list of dashboards available to your project. Each Smarthome project will have a Smarthome Analytics dashboard available to them. So clicking through it should bring you to this page with your analytics. Let me refresh the page. So the calls that we issued will take some time to propagate here. within your metrics. Okay, there you go. So I issued 2 calls. You'll see the Smarthome requests will show the total number of requests my project is handled. The request shows out as 2 requests in line with what we have tried. One of those requests have failed and one of them has succeeded. So our success percentage chart shows the success rate as 50%. Then we do have 2 charts that shows us different breakdowns for our requests. On the left, you are going to see the executions. On the right, you are going to see queries. It will only show the successfully executed requests. And our successfully executed request was an on-off. So in the trait breakdown, you are going to see an on-off trait here. We didn't issue any queries. That's why the chart will be blank. Then scrolling down to our other set of charts, the latency graph is a 95th percentile latency of the request that we handle. And the number that we see around there is around 900 milliseconds. We see that our active user graph that shows the daily active users does not have any data, because since all our charts populate nearly at an instant time, the active user chart populates at the end of the day once throughout the day. So you are going to be able to see the number of active users you have for the last 24 hours. That means the active usage that I've created right now will be visible when you take a look at this chart tomorrow. Then local fulfillment errors will have data if you have a local home implementation. And also our last chart that I would like to show you is our Smarthome error breakdown chart. This is going to be the most important one when you are going after your errors. Hovering over this will show you any errors you have on your project and their error codes. The error that we have with our okg pause my washer command came out to be displaying an invalid JSON command. Okay, so we'll take this in mind and go back to the presentation. So we have monitored our errors. To recap the monitoring, from the charts that we have seen, I think there are 3 key ones that can provide great deal of insights to you to monitor your quality and in terms of debugging. Success percentage shows the overall success percentage of all Smarthome fulfillments, as you mentioned, and request latency shows the 95th percentile of perceived latency on Google servers. Different devices does have different requirements, of course, for these. So I recommend checking the specific guidelines from our documentation. But for a washer device, as we have in this workshop, the success percentage should be above 97%, and the latency should be below, hopefully, 3000 milliseconds. The latency we saw on the graph was around 900 milliseconds. And we also have the error breakdown chart, which is crucial, as I mentioned, for monitoring your errors. And as a reminder, the error code we have seen there was invalid JSON. So knowing that, we are going to proceed our step number 2, which is searching through our error logs. So for that, I'm going to open up the Log Explorer. Again, how you can access this window will be when you get to Google Cloud Platform. Through the side menu, scroll all the way down to Operations again. This time logging, then Logs Explorer should bring you to this page. Let me refresh the page. So we have all the logs. Okay, so we remember our error was invalid JSON. So I'm going to type this to the query builder field above, invalid JSON. So this page does have an query builder on top and the list of all logs available to our project below. you'll have multiple logs that come from many different sources, not only Smarthome. So many different pipelines through Google Cloud Platform will generate logs to your project. Like your account settings, billing, they might have logs here. That's why when you go after certain types of logs, you need to be able to filter the logs that you want through all the logs available to your project. We are after logs that should have invalid JSON in them. So I typed it up as a string in quotation marks. Then I'm going to do a run query. Let's see if it's going to be able to find some logs. I had been testing this project over the last few hours, so I might have multiple invalid JSON logs here. I'm going to open up the most recent one. So a log that we have will look like this. It does have many detailed fields in it. And the last log that I have for an invalid JSON does specify a request ID, execution type. For the device type, device trait, it is going to have a latency that can help you to maybe uncover an issue with your implementation. Then under the status field, you'll see is success is going to be represented as false because this is an error log. Status type will indicate our error code. Invalid JSON we see here. This is actually what makes it searchable through our logs. The name here matches what's available in our metrics. That's why what you see in the error breakdown metric, you can search within these logs. And for the most important, you are going to be able to see an external debug string here. This is a more explanatory error message that can uncover what is wrong with your implementation. So this one actually says JSON response does not include the device. So maybe in our intent handling for our execution functions, maybe we forgot to include the device, or there's an error that prevents us to include the device. So we are going to go back and check our execution functions when we are ready to do our debugging. And you have seen how to filter things through logs. Coming back to the presentation again. There are a few other comments that I would like to mention for the logs. Similar to what we had done, we can also fetch certain fields within the log, like is success equals false and is the device type equals light. This will filter our logs for errors come from lights. You can also combine these prompts with Boolean operators, such as and or not. And for numeric fields, you can use comparisons, such as latency millisecond greater than 300 will get you the logs that has a higher latency number. So you are not only limited to string searches, there's a few different steps that you can take, and you can use these filters to actually find creative ways to investigate your errors. Google does provide a query library that has many different examples that you can use, and I have put the link below so you can go check it out as well. Okay, moving forward, let's turn to our code to do some debugging. We have mentioned that our functional code is stored in functions directory. In there, you'll find an index.js file. This file has all our implementations for the intent fulfillment for the Smarthome implementation we have. Our Google Smarthome ecosystem defines three main intents: sync, query, and execute, that handles different capabilities when it comes to user intents. You'll recall that we noticed our error when we issued OKG pause my washer command. This is an execution intent. So we are going to start our debugging through our execution function. This is at line 210. In there, you are going to see several different nested for loops. First one goes through all the commands available. Looking at the code, I'm seeing the second one gets all the devices from the command. Then another for loop that goes through all the pending executions. Then for each of these executions, we are creating a JavaScript promise and calling this update device function. And there isn't much else available in this onExecute function. So if there are any errors within our code, the chances are it's in this update device function. So this one, you can find it in line 186. Taking a look at the update device, we'll see that it's an asynchronous function, a few variable definitions. Then you'll see a beefy switch that compares the command value coming to different cases. In our implementation, each case represents a trait here. And if you look closely, the pause unpause trait actually has an extra pause at the end. So we are deleting that extra pause from our code. This is also actually a very common error that we have seen across many developers. So always double check your trait names. Once we fix this issue, we'll do another Firebase deploy command, then retest our action. I took another video and let's see how this one goes. This time, OKG, pause my washer. And again, I've wrote the outcome. This time the answer comes out as sure, pausing the device. If you recall, it was previously, sorry, I couldn't reach the action name. So I can confidently say, congrats, we fixed our first error. Though the way that we have tested our action was through issuing a few commands, then checking the behavior that comes as responses through Google Assistant. This is an easy way to test the general behavior of a maybe single device, but not much so an effective way to test your whole implementation. For a more comprehensive test, we will use Test Suite. Okay, so we advanced to the fourth section of our codelab now, which is to test your action with Test Suite. This page of the codelab will give you the steps to run the Test Suite, but I'll give you another quick intro instead. The Test Suite is our test platform for smart home actions. The tool requires project ID to identify your project and a signed-in Google account with devices to test. It checks which devices are available on the account linked to this project and generates an automated test plan, then runs through these tests by issuing commands, then checking the state changes. The tool overall provides regression testing capability through your entire application lifecycle. And also, this is a tool that we recommend you to run periodically to catch any errors before releasing your project to production. Test Suite is available through the link I provided below, smarthome-test-suite.withgoogle.com. If you have used Test Suite already, you'll realize a lot of changes through our most recent updates, by the way. The tool does not rely on text-to-speech anymore. It sends requests directly to smart home servers by simulating user intents. We have also introduced query support, which allows us to identify discrepancies between report state and query results. Also, the tool works without requiring service account key or an agent user ID to offer greater flexibility to run tests across variety of implementations. So the Test Suite, how it works behind the scenes, you'll provide us a sync response for each of the device the user has. We check the device type and traits and prepare a comprehensive test plan for the user. For every trait, we'll at least do one test by issuing an execution intent, then listening back the state change via report state. Then we'll also do one test by issuing a query and another comparison tests to compare the results to match the query with report state. And for Boolean traits like on-off, start, stop, we'll actually do a set of tests for both cases and numeric values like temperature, we'll do a test for the minimum, one for maximum, and a value in between. So you'll see multiple tests, at least multiple tests, for every single trait you have for all the devices linked to the place. I did grab a quick video, by the way, on how the test suite runs on my project. So I'll start by going to the link, then I do have a Google account logged in, then typing my project ID will show all the devices and traits I have. Then we do have extra functionality, like do we want to test the requesting, test scene, or a few other functionalities. We don't need them for our test now, so I turned all of them off. Then clicking start is starting my tests. Test suite will take probably a few minutes to go through all these tests, but to give you an idea, basically for each trait, as we mentioned, it's gonna conduct a series of tests. So as I mentioned, this will take some time. I'm gonna fast forward the video to the end result. So test suite is gonna outline that we still have a few other errors yet to catch through this workshop. And when we look closely to the test suite results, we see that it says the expected state to include is paused equals true, but the actual state does not contain the is paused result. As a result, both the execution report state pair as well as the discrepancy check for the report state and query pair fails. From our earlier test, we know our execution works now for the pause command. So this new issue has to be on the report state. So going back to our code, our report state implementation is at line 277. You'll see that we are building a request response by including a request ID, agent user ID, and a comprehensive list of states available for our device. A careful look on the list of states, and you'll realize that we have is paused missing here. So we'll add the is paused, then the extra bit on the right fetches the value from our database. We structure the states, including the is paused now. We save our code, Firebase deploy again, and we'll do another test suite test. Let's see how this one will go. So we are gonna write the project ID again. Then this time I'm not gonna spend much time to go through all the traits, but you see all the traits available to our washer, on, off, start, stop. And when all the type and trait implementations work correctly, tests usually take slightly less time, but I'll still fast forward to our end result, which is going to be this one. Okay, so after our change, we see all our tests successfully passed now. One additional comment, some traits you might see not supported, as in the case in run cycle. We still have a few tests that test suite doesn't check or cannot test. For those you might see not supported and might end up manually test them. But for a wide variety of our types and traits, a test suite is going to be able to do a comprehensive test plan and execute it automatically. Okay, so congrats catching the second error as well. As a recap on everything that we had done so far, we have learned how to monitor our errors by using the error breakdown and recording the error code. Then we learned how to use the Logs Explorer to filter through our error logs and found the error log matching our error code. Seeing the error description helped us to fix our first bug. Then we have also covered how to use the test suite, our regression testing platform, And I do recommend to use this tool whenever you are testing for a bug, testing after a change, or even periodically to ensure your smart home integration works smoothly. So keep that in mind. And after covering all of them, I would close by thank you so much for staying with me throughout the entire talk. I hope the Smarthome Analytics and Test Suite will be both useful to achieve a reliable and error-free smart home project. You can learn more about these tools and also more about our ecosystem through our main documentation link at developers.google.com/assistant/smarthome. And my name is Yiğit, Technical Solutions and Engineer at Google, working on data analytics solutions for IoT devices. Feel free to reach out to me with any questions you have. And looks like we are finished with our call. I'll also have a chat open with my colleagues to see if we have any questions in the Q&A. I hope this talk will be useful to all developers. Let's see how the Q&A looks like. Okay, so as I mentioned, the Q&A will stay open for the next 24 hours. So you can go throughout this workshop on your own pace. If you do have any questions, you can keep asking throughout the Q&A. Either I or my colleagues, we are going to monitor it periodically and try to answer your questions. Okay, looks like we do have a question. My colleague is asking, is there any latency requirements for launching a smart home action? Okay, so we do have our certification program, or all smart home actions launching to the entire world does have to pass through those requirements. They are based on your device types. So different devices will have different latency requirements. I don't have all of them on top of my head. For a washer, as we covered, we do have a success percentage requirement and a latency requirement. And for many of the other devices we have, there are going to be even other requirements as well. So you can check our documentation for that. Okay, looks like we are ready to wrap up. As I mentioned, the Q&A will stay open after the talk. Thanks for staying by to the end of the talk. I hope you have a good day.